Hey mathematicians, it's your very first homework assignment of 6th grade. We're going to do it together. Okay, so the first 3 problems are number lines. Now, these number lines are missing a bunch of numbers and it's your job to fill them in. They're not counting by ones. So instead of saying 0, 1, 10, because that's not the way we skip count, it's your job to figure out, okay, if there's only one number in between 0 and 10, what can it be? 5. 0, 5, 10, 15. Oh, I even see a negative 15 on this side. Okay, I think that might be our pattern. So then you fill it in, and you fill in all of these numbers, and then let's double check here. If this is 0, that's kind of our midpoint, our line at which numbers on the right are positive and numbers on the left are negative. So if this is positive 5, then we're going to have negative 5 over here. Negative 10, negative 15. Okay, our pattern works. You fill in the rest. Same deal down here. 0, if the negative 8 is freaking you out, think, okay, what would be in the middle of 0 and positive 8? Because positive 8 will be right here with one number between it and 0, just like negative 8 has one number between it and 0. So what is halfway between 0 and 8? That's the number that goes right here. And make that number negative, and that's what goes right here. And that's what you're skip counting by. 0, 4, 8. What's 4 more than 8? 9, 10, 11, 12. Oh, wait a minute. It's kind of like your 4's times tables. So you're filling that out with the rest of the numbers. This one at the bottom is the hardest one because I didn't tell you where 0 is. So you need to do kind of some guess and check before you start writing in with pen or something. Okay, 4, 3, 2, 1, 0, negative 6. That doesn't sound right. 4, 0, negative 4, negative 8, negative 12, negative 6. No, that doesn't work. 4, 2, 0, negative 4, negative 2, negative 4, negative 6. That actually sounds like it works. 2, 0, you fill in the rest. Create a number line that shows the numbers negative 12 to 12. That means negative 12 is right here. 12 is right here. And you need to figure out what we're skip counting by, where 0 goes, hint, probably right in the middle, and fill in the rest of the numbers. Okay, I promised everyone that I would definitely do this. The definition for a whole number is a positive number not a decimal or a fraction. Now, I said positive, but it could also be 0, which is not positive or negative. So an example of a whole number, you could say 0, you could say 1, you could say 29, you could say whatever positive number or 0 that you want. It just cannot be a fraction or a decimal. But actually, it kind of can be a fraction. It cannot be a fraction that does not simplify. If I put the fraction 100 tenths, that is the fraction 100 divided by 10, and that equals 10, which is a whole number. I can put a fraction if when I actually do the division problem, oops, my lights went off. If when I actually do the division problem, it gives me a whole number. A non-example would be like 99 divided by 10, because that gives me 9.9, and that is not a whole number. Integers are whole numbers and their opposites. Let's see. 0 is an integer. The opposite of 0 is still an integer, 0. 1 is an integer. It's also a whole number. You could also say negative 1. That's not a whole number. It's just an integer. 29, that's an integer. Negative 29, also an integer. What's not an integer? Negative 29.1, no decimals. Negative 29 divided by 2, because that's a fraction that does not simplify to a whole number or an integer without like an integer. It does not simplify to something that does not include a decimal or a fraction in its final form. Rational numbers are all the numbers we dealt with in 6th grade. All numbers we see in 6th grade, because there are other numbers like we talked about when we talked about irrational numbers that exist in the world, but not that we deal with in 6th grade. So we're talking yes to 0, yes to -1, yes to 1.25, yes to 27 thirds, which actually simplifies to a whole number, yes to 27 fourths, which would stay as a fraction. No to irrational numbers that we don't deal with in 6th grade. We will not deal with pi. We will not deal with imaginary numbers. We will not deal with square roots. We will not deal with numbers that you divide by the number 0 because that's not possible. Those things are irrational numbers. Everything else that we deal with in 6th grade, we can call a rational number. All right, on the back. Josiah's classmates said the following thing. Kat said, -4 is an integer and a rational number. Orly said, 0 is a whole number, but we can't call it an integer, and we can't call it a rational number. Hamilton said, -2/3 is an integer because it has a negative sign. I'm not telling you 1, 2, 3 of them are correct. I'm not telling you how many people are wrong. I'm asking, is anyone right? If anyone is right, I want to know who's right and why you picked them. So what I'm looking for is probably 3 sentences. Kat is, you tell me, right or wrong? Because, why? Orly is, right or wrong, you choose, because, why? Hamilton, Ilton, is, because. Now, I already told one of my classes that Hamilton is wrong, so I'll tell everybody Hamilton is wrong. Because integers just don't mean any old negative number. Yes, integers can be negative, but integers cannot be fractions. So that would be my because statement. Integers can't be fractions. So now you just need to make a decision, is Kat right? Can we call an integer, and can we call -4 an integer? And are all integers rational numbers? Orly says 0 is a whole number, but that it's not an integer and it's not a rational number. If you're still stuck on this, watch me do the next problem, and then maybe you'll have a better opinion on it. All right, it's the last problem in the homework, and then you're done. Tony created the Venn diagram shown below. That's when they're like the circles that are layered over each other. Is anything wrong with it? Let's find out. All right, I'm going to use my highlighter tool. Let's see if we can get some fancy new colors up in here. All whole numbers are these whole numbers. Is 0 a whole number? I think so. Is 4 a whole number? Yes, I think so. All right, I think those two are good. Now let's change our highlighter color. We're going to go for blue. Integers. I'm shading the integer circle. Is everything covered in blue an integer? Well, now I just made the yellow green, but we'll pretend that you can still say it's yellow. Oops. 0 is also an integer. That's true. Because the whole number circle is inside the integer circle. It's like saying, I'm in Miss Douglas's homeroom, which sadly no one is this year because I don't have a homeroom. But I'm also in the 6th grade. You can be both things at once, but not all 6th graders are in Miss Douglas's homeroom. So not all integers are called whole numbers, only the ones without a negative sign. These two on the outside, this -8 and this -0.5, are negatives, but are all negatives integers? Last but not least, let's make this one, bright pink. Everything in here, that was a bad choice. Now you can't see any of those numbers. Well, I hope you remember what they are. Everything in here is a rational number. That is true. Everything in this circle is a rational number because all of those are numbers that we could deal with in the 6th grade. Now, the only issue is, let's see if I can undo what I just did so you can see it again. There we go. We'll just shade on the sidelines. The only issue is are all these rational numbers placed in the correct integer or whole number section? You have to write me a sentence giving me your opinion on that. And now we're done with our homework. That wasn't so bad. So scrolling back up here, thinking on this, is 0 a whole number? Yeah, we saw 0 here. But did we also shade it with blue and pink? We did. So 0 is a whole number, but it's not an integer and it's not a rational number? Excuse you, they all got shaded with pink. And -4 is an integer and a rational number. Did we shade the integer level with both blue for the integers and pink for the rational numbers? Don't forget to write me incomplete sentences, please.